Simple harmonic motion has 3 different variables: displacement, velocity, and acceleration. Now, these are just like our variables that we have used before.
Mm-hmm.
Displacement, we use x, velocity v, acceleration a. When we're talking about these variables, though, in regard to simple harmonic motion, we have different variables. Velocity is lowercase Greek omega, which the boys last year in AP Physics called booty cheeks.
It does kind of look like that.
Lowercase Greek alpha is like the Jesus fish.
Yeah.
That's acceleration. Displacement now becomes theta.
Okay. Yeah.
Not in the angle, but in the number of radians. That doesn't mean we're going to be using radians in the mode on our calculator. It just is what we're going to use to like talk about
Gotcha.
the things. That's not a circle.
Almost.
That's very nice of you. All right, so when we're talking about harmonic motion, we can really think about the motion of a circle, because as our object is bouncing up and down, if we had like a ticker tape that was going to be drawing out our patterns, we would see this.
Mhm.
But what that really looks like is an object moving around. Like here would be your upstroke and your downstroke.
Yeah.
And so this is not like circular motion. It's something different. But we use the circle as the reference to help us understand and like visualize what's happening. Gretchen, it looks like you're dying over there. Are you all right?
I'm checking.
You were just.
He's on his way, but it's gonna take him.
Yeah, I know, the upping and downing and
Upstrokes, downstrokes.
Okay, Gretchen.
okay,
Gretchen,
so
go get the food.
if this is
Not here.
if this is where our particle begins
I'll tell you when it's close.
and this is where our particle ends, this displacement, like the greatest displacement, is that A we talked about last time, the amplitude of this wave here. Well, I maybe didn't do this right, because, hang on, that arrow was a little bit jinky. So if this is your equilibrium position, A is the distance between equilibrium and then like the high part, the crest.
Yeah. And that's the same as the radian.
Yep.
Not radian, radius.
Yes.
Okay.
Yes, it is.
Yeah. That makes sense.
Okay, so the reference circle uses this x here as what we think about for our displacement. Because what really is happening is that, because we're not in circular motion, this is just like a way of representing this motion of the wave. So let me just, oh, I did this wrong. I apologize. The displacement really still is x.
Yay!
I'm sorry. The theta is this amount there. Good thing I have my notes today. And so then we do need this formula. X is equal to a cosine of
Theta, right?
well, yes, but theta is equal to velocity times time.
Okay.
So you should be able to find this formula on a blue sheet.
Simple harmonic motion. W equals. X equals a cosine WT.
Yep. Got it.
Another property that we should know is that the velocity, angular velocity, is going to be equal to 2 pi divided by t. Big T is?
What's it
Oh,
called?
big T equals
So,
tits. Ah.
okay.
Yeah,
It's
I
like
think I
per
didn't remember
the
it.
rounds per time. What's it called?
Yep. It has a name.
Shoot. is your name?
It's the period.
Oh.
So
This
the,
is kind of
the
close.
period is the
Did you
time.
say tits was kind of close?
I mean, not yeah. I guess it's the time it takes for one revolution.
Yeah.
Yeah. That's what it is.
And so it can sometimes be confused with the number of revolutions in a second. That's actually what angular velocity is. So where do we get the 2 pi from?
He's all the way over here, dude.
Where do we get the 2 pi from?
That's would be
From the
Circumference. Yep, that's where time comes from. So really, angular velocity then is number of revolutions per second. Which makes sense to us because normal velocity is meters per second or distance traveled per time. And so here, you're calculating angular velocity by the circumference of the circle, basically, divided by the time it takes for one revolution. Okay, so the only other thing, a couple of things that you need to know, frequency and period are related. I'm gonna have to get rid of my reference circle. Frequency and the period are reciprocals of each other. Frequency's unit is always in hertz, which is the same thing as like 1/second.
You said frequency and period are reciprocals?
They're inversely proportional. And so frequency tells us the number of times something happens in a second.
Okay.
And so if we are saying that this is true from this equation here, and we know that frequency equals 1 divided by t, angular velocity is also equal to 2 pi f.
Oh, okay. Yeah, that makes sense.
And then the last thing that you need to know is probably the most important part of this whole lesson. You can also find an angular velocity using what you know about the spring and the mass of the object attached to the spring.
yay.
So a couple of assumptions that we are making assumptions that it's an ideal spring, and so friction is not a thing. And then the other approximation or assumption that we're making is that the spring itself is massless,
Okay.
which makes no sense cognitively, right? Because in order for it to be a thing, it must have mass.
For it to be springy, you gotta be springy.
Indeed. Okay, so I have some homeworks. I already gave you that page there. I've got some example problems, but I think you guys probably are capable of going right into the homework. So if you have problems with these, I can help you with some of this stuff.
Sounds good.
But homework number 7 will be page 304 to 5, numbers 17, 18, 20, 21, and 24.
Alright.
I'm not sure if this is on your AP formula
I'll tell
sheet.
you when he gets like around.
Can anybody look? Does anybody have their AP formula sheet out really quickly?
Yeah.
Can you see if your AP on your? No, that's mine. Carter, look at yes. See if this is on there. For some reason, I have a feeling that this is not.
Electricity, waves, temperature, doesn't appear so.
This is one of the most important formulas that you're going to use, and I'm pretty sure it's not on there. I would definitely make sure that I made a note to myself on my calculator or something.
Yeah, it's not on there.
Get a tattoo of this, perhaps, because
Real.
this is not on there, and it's something that you'll need.
Imagine like somebody tattoos a unit circle on there.
Yeah. Well, I had a friend in college who had the Schrodinger equation tattooed on his left forearm.
Wow.
Yeah, like what do you do then?
Well, if it's a real tattoo, they can't make you cover your body,
Yeah.
so he could use it. Okay, so let me know, Lindsay, if you have questions.
That's a Chromebook.